Hello everyone, this is Mrs. C and I am here with you today to give you an overview of all that you should know when you're solving complicated linear equations. And so if the things that I'm doing in this video are too much, too overwhelming, too confusing, what you're going to need to do is you're going to back up. So I'm going to try to lay that out for you so that you know where to go with regard to how much you need to know and what you need to do to get that knowledge. So what I'd like to do is start off with a screenshot of some problems that I got off of our CUDA website. You can see, excuse me, you can see up at the top the address. Do that to make it a little bit easier for you. Honestly, I don't think it is easier. If you want this worksheet, you want more practice with problems that look like that, you're going to go to CUDA as always. You're going to spend a lot of time in 2014, 2015, not 13, we're not going backwards, on the CUDA website. And so the address is right there, not that part. Okay, www.cudasoftware.com. When you get there, you're going to see a screenshot that gives you options. Look where I went. Algebra 2. I know you're probably thinking, whoa, Mrs. C, did you get confused? This is an beginning of Algebra 1 class. I know, but your teacher last year did so much with you to get you ready that I know you know this stuff. So this is a review for Algebra 2, and it's going to be a review for Algebra 1 in many cases. If not, you're going to go back and fill in the gaps, and I'm going to be here to help you out. So let me back up, and let's take a look. Now, you're going to find I always will encourage you to practice problems that you know the answer to. And I like that problem. One of the reasons I like it, the answer is 1. I mean, really, how bad could it be? The answer is 1, right? So what I would like to do is I'm going to move it over to the next page, and we're just going to break this problem down. I'm going to show you the steps that you should already know, you should be following in order to solve this and get the answer 1. So I'm going to pause you. You're not going to know that I'm pausing you because it's not even going to seem like I was gone. And poof. All right, so you're going to see problems evens 12 through 18 have slid over to the other side. That's just going to give me more room to work on the right, but yet we can still see problems if we want to refer to them. So the one that I picked was number 14. I'm just going to recopy it. Here we've got negative 16 plus 5n. You should be doing this as well at home. Negative 6. Oh boy. You keep copying. I have to write smaller. Got to get the hang of this. Tiny eraser. Alright, write smaller, write smaller. Write smaller. Can't make my font much smaller. I'm going to try it. Sorry. Technicalities at the beginning of the year. Just have to get it all together. Alright, here I go, guys. Let me try this one more time. Writing smaller. We have a negative 16. Wait till you try this. You're going to start doing screencasts too, and you're going to see how hard it is to write small with a stylus. Might I just say, it is a learned skill. There it is, best I can do. I've got a negative 16, and what I'm doing right now is I'm looking at this. I am looking at this to make sure that I copied it properly. So you should always do this when you copy a problem. Double check. Negative 16 plus 5n equals negative 7 minus, times the quantity, of negative 6 plus 8n. Close the parentheses. We got plus 3. We are golden. We are good to go. All right. So the first thing I'm going to ask you to do that no one's asked you to do before is what I think is really important. I want you to do what I call divide the field. Now, by divide the field, I mean to just draw a line down the center. And the reason is you are going to see if you can simplify anything on this side. Then you're going to come over. You're going to see if there's anything you can do to this side. And you're going to do that first. You're not going to move anything from side to side. You're just going to simplify. So let's go back over to this left side. The negative 16 plus 5n. Can I do anything to simplify that? Can I combine the terms, multiply, add, subtract, divide? And the answer is no. And the reason, you may already know, is because they are not like terms. A negative 16 is a constant, a 5n has a variable attached to it, and therefore there's really nothing I can do. You stay the same left side. Coming over to the right side, negative 7 times the quantity of a negative 6 plus 8n, and then on top of, after doing that, you got to add 3. Is there anything that I can do with the skills that I've learned in the past? And the answer is yes. So here we go with the first skill that you're going to apply. I refer to as the loop method. No, it's the distributive property. So when you use the distributive property in this case, we would wind up with a negative 7 times a negative 6. That's the first loop. That gives me a positive 42. And then a negative 7 times a positive 8n. That gives me a negative 56n plus 3. I'm just bringing down that. Now I'm going to make it a little smaller while I talk to you. Do you remember the distributive property from last year? If you don't, then you're going to stop right now. So sorry to see you go, but you're going to need to. You're going to stop, and you're going to find a video. You're going to bring that plus 3 down. You're going to find a video on the distributive property. You're going to practice that. That would be in simplifying expressions using the distributive property. You're going to practice that skill because you can't do these more complicated. Look at them. They all have these parenthesis sets, and you can't get through them without knowing the distributive property a little bit better. So go on, get going, go find yourself some more practice in that, and then come back to this video. For those of you that say, oh yeah, I remember this, well, let's keep going. Bring down the left side, negative 16 plus 5n, and I still have this divided field. And again, the field is dividing the sides until you figure out if there's anything else that you can do. So if I go to the left, there's still nothing I can do. I still copy it, but look here. A 42 and a positive 3, they're constants. They don't have a variable like the negative 56n. So when we have the 42 and the positive 3, we can combine those using the rules of addition. Same sign sum, different sign difference. So in this case, same sign, find the sum, that would be a 45, keep the sign, positive. Had they both been negative, negative 42 and a negative 3, same sign sum, still would have been, I caught it. Did you see my mistake? Always be on guard for my screw-ups. Okay. Had it been a negative, then it would have been a negative 45 because it would be same sign sum, you'd still add. But in this case, keeping the sign would have kept it a negative. What if one of them had been negative? What if it had been a negative 42? Well, then it's different signs. One's a negative, one's a positive. Different signs, find the difference. That would be 39. Keep the sign of the higher number. 42 is bigger than 3. It would have been a negative 39. So all those rules that you learned in the past, we are using them every single day in algebra. We just bring down what was left. There, negative 16 plus 5n. Okay, once we see that there's no more combining, I can't combine them, they're not like terms, that's when we start moving things over. It's called transposing. And so when we transpose, it's really important that we only transpose like terms to other like terms. Let's help with a little color coding. There's a constant. There's a constant. And let's do a nice little blue. There's a variable term. There's another variable. So what we want to get is the reds with the reds and the blues with the blues. We want to bring them together using the rules of algebra, which means whatever you do to one side, you can do, but you have to do equally to the other side. And so what I'm saying is, let's get the blues together. I almost always try to put my variables together. So find the blues. All right, I want my blues to be on the, let's say, left. Let's always move the variables to the left, and then let's always move the constants to the right. And, you know, that'll just keep things the same. Doesn't matter at all if you do that, but when we're working together, it kind of helps to have a plan. So to move this blue, over to this blue, I'm going to add 56. I hope you remember that. Opposite operation. Okay, that will cancel that out. And then we use our same sign sum, different sign difference, rules of addition of integers. So we have same sign, that's a sum. 56 and 5 is 61. And then I'm just going to, it takes a little, the color coding, it takes a little bit of time. So please bear with me. I want to put everybody back. This is usually when I make mistakes because I'm too busy thinking about colors. I'm not thinking about the math. So here's these two. These were the reds, right? I was going to move the reds to the right. I'm going to add 16. I'm going to add 16. That'll cancel that out. And it'll give me my red. 45 and 16. That's 61. A little math in your head, right? And then on the other side, I have a blue 61N. Okay, well, so here we have it. So far, so good. We have a 61N equals 61. Now, the color coding was just to get you to see this. You have to combine the like terms. And so n's with n's, constants with constants. Color coding is really not useful at this point. So thankfully, I think I can just go back to the same color. Let's go. 61n equals 61. And in fact, I think I would like to go to the next page. We're at 61n equals 61. Just give me a little bit more room to work. There was a line separating the left and the right side. Now, ultimately, we are trying to get n by itself on one side of the line and then numbers on the other side. Now, before, if I just go back real quick, I did what operation to move the 56n and to move the 5n? What operations did I use? Here and here. Did I add, subtract, multiply, divide? I added, right? Okay, so when you are moving terms to the left and to the right whose relationships were addition and subtraction, you see it up here. Addition and subtraction. The relationship between the numbers and the other numbers is addition and subtraction. There's a little bit of a difference now. This relationship is multiplication, you see. We don't put the dot, right? But this is 61 times n. Because they're touching and there's no plus sign or minus sign in between them, the relationship is multiplication. Whatever n is, you're going to times it by 61 to get your final answer. Well, you could ask yourself in your head, what would I have to times that number by 61 and still stay a 61? Well, n would have to be 1, and if you remember, we already knew that. But you don't have to think that hard. The relationship between the 61 and the n is multiplication. To undo that, we use the opposite operation to both sides. You divide. 61 divided by 61 cancels out to a 1n. 61 divided by 61 is just 1, no n. And there's our final answer, always boxing our final answer. Bar down the center, optional at this point, but it's fine with me if you want to use it. So the answer, as we already know, because we can see it right here, is 1. And it's a really good reason why you always want to work with the answers, because if you don't get 1, you know you screwed up somewhere, and you got to go back and figure it out. All right, let's move on to another problem. Okay, I think I'd like to try number 16, and I'll tell you why after I take a sip of coffee. I think I'm going to need a sip of coffee to do this problem. All right, let me explain why I like doing problem number 16. The reason I like doing problem number 16 is because I see more mistakes with answers that are 0 than I see any other mistake, I think, in all of my algebra classes. Why is that? I'm not exactly sure. I think there's a lot of haters of 0 out there. I think some people think if they get 0, they did something wrong. Maybe we just need to do problems whose answers are 0 more and not make poor 0 have such a bad rap. Because, you know, I get answers of 0 all the time, and I don't freak out when I get them. I just think, oh, the answer is 0. So I want you to be the same way. I want you to have the same reaction when you get a 0. So dividing my field just to keep things separated until I clean things up a little bit. And there's cleaning all over the place. The first thing I do, I look for an opportunity to use the distributive property. I will always distribute before I do anything else. Almost always, until maybe these problems get a little saucier, but they're not going to get saucier than this for a while. So let's just always look for this opportunity here and here to use the distributive property. Now, you're always going to bring down that number, and sometimes I think it's a good idea to bring it down first before you go and forget it. Let's do 3 times 8, that's 24, but don't forget, it's positive 24. You need to put the plus sign in front of it. And then 3 times 8, well, again, that's 24, but it's an n. So now we have plus 24n. Awesomeness. And then we come over. Again, we distribute. Don't lose that little negative. It's kind of hiding there. That's a negative 6n plus 24. There's a lot of 24s, huh? So, again, negative 6 times n is negative 6n. Negative 6 times negative 4 is positive 24. Are both sides cleaned up? This is because I can't combine anymore. I can't do anything else. I can't put a 6 and a 24 together and get 30. I can't subtract because they're unlike terms. So I'm done with that sign. I'm done with you. You're dead to me. Come over to the left and take a look at that. Now, you should almost always be able to get them into a binomial, which means that's 2 different terms that can't be combined. Do you see who the 2 terms are that can come together? I hope you can. The n's. Now in this case, before we had same sign sum, we have different sign difference. We have a negative 10 and a positive 24. Subtract and you get 14, that's right. Sign of the higher number, positive, and don't forget the n's. So we had a positive 14n. Now, positive 14n. Do I need the plus in the front if I'm just going to bring that 24, this 24 down? Do you need to put a plus sign in front? No. If it had been a negative, if the signs had been reversed and been a negative 24 and a positive 10, then yeah, you would have had to put a negative in front. But we have this little assume it's positive if somebody doesn't tell you otherwise rule. I love that rule. Less for me to write. So I don't have to write the positive. You can if it makes you feel better. Go ahead and write. Watch. I did it. Nothing's going to happen. So left side clean, good, can't do anything else. Right side clean, good, can't do anything else. What we want to do is combine like terms, but we've got to go over, we've got to cross the wall. Whenever we cross this wall, whenever we go over from one side to the other, you have to use opposite operation. We didn't use opposite operation up until now because we were combining. We have to use opposite operation now because we are transposing. We are going over this wall. We are breaking out of jail. It is something that has to have some other just effect. You have to do something different in order to pull it off because it's different than just combining. Doesn't that make sense if you just think about it? There's got to be a different method to do something different. So now I said just always put your letters on the left and your numbers on the right and keep it simple. So let's just do that. If letters are going that way, then find the letter that's on the right end, move it. That would be the negative 6n. You have to move it by doing the opposite. That would be plusing 6n to both sides. Now you're going to hopefully see that the little positive that I put in front of the 14 really was kind of unnecessary because we knew it was positive. So we knew their same sign, sum, keep the sign. So that's going to give me a 20n. And then I said just move the letters over. That would be this guy moving over. And first I have to bring down because I'm very picky about making sure you bring down. Okay, minus 24, minus 24. Okay. Well, there it is. 24 minus 24 is 0. Now, I'm going to try to if you don't mind, and I hope this doesn't freak you out, but I am running out of space, and I don't really know how to fix that. So I'm going to just say, didn't we say that was 0? So it's gone. It's not there. It's nothing. And didn't we say this was 0? It's gone, and it's not there. Now, in order to make things look good to our brain, we got to hold the space on the right with a number. And what number represents nothing? 0. Do I need to put plus 0 here? Not really. I don't think you do. I think you'd be okay with not having that there. So, less is more. Don't put it if you don't need it. We did need it on this side, though, because without it, it just looks weird. It looks strange. It looks like it's missing something. So I put it. So there. Last step is to just ask yourself, well, 20 times what would give me 0? There is only one answer to that, 0. The only way you get 0 is by having 0 in your multiplication or division. Now, I have to divide just to show the step. I'm going to undo what's being done. This is being times. And so to undo that, you divide both sides by the number, 20. That's going to get the n by itself. Any number that you divide 0 by is going to render you the answer 0. So the answer n equals 0. If you forgot, put it in the calculator. 0 divided by 20, 0. And then here we go. The answer was 0. All right, so what do we make of all that? Well, that never erased. I never erased it. What do we make of all of that? Well, first thing you might notice is, gee, that was a lot of information. And depending on how good you are, it would kind of put you in the direction of where you need to study. So if you followed along with what I just did, you have 2 places to go. The CUDA software, and I will just write CUDA, so you'll get the hang of what I mean when I write CUDA. The CUDA software, you can go to either the Algebra 1 or the Algebra 2. Okay, Algebra 1 or, that looks like Algebra 1/2, doesn't it? Well, I just can't do that. Okay, Algebra 1 or Algebra 2 will give you a review of what is called solving linear equations. That's what these things are called. Now, if you were confused with any of this distributive property that you saw, if that gave you a hard time, then what you're going to do is you're going to check out simplifying expressions. Now, you're going to have to search for the ones that have the distributive property or find a worksheet somewhere where they actually specifically just practice simply distributive method. If you would like one from me, I can easily post one for you on your Google Drive. So just let me know what you need and I'll get it on there. Now, next up, if this part, if just the basic you get the distributive method, but you are looking for more simple equations, you want to go to the CUDA again. You want to stay only in Algebra 1, and you want to look at the top of the page. The top of the page is always easier than the bottom. Now, for those of you that stuck through this video and just want more practice of what we just did, I am going to pull up the sheet that I had before. You can take a nice little screenshot of this. Now, we did, about 2, right? 2 of them. I don't think I have any more there. We did the 2 of them, and let's identify the ones that we already did. We did the one that gave us the answer of 1. That was this one, right? And we did the one that gave us the answer of 0, and we did this one, not the other one. Now, no solutions, I would just avoid at this point, because I would like to have a separate video just on no solutions and all real numbers before you start practicing it without me. Now, if you want more instruction on that, and I haven't made the video yet, talk to me in class and I'll do a little lesson with you on the side on no solutions and all real numbers. But what we need to do is practice our skills, and you can see you have plenty of practice here, 11, 12, 13, 15, and 17, and if you seek out more, you know where to go to get it. So listen, this was an awesome time. I enjoyed it. My coffee's getting cold, so I have to get back to it. Hope you enjoyed our review of equations. Peace out, and I'll see you on the flip side.